All right, so good afternoon. I hope everybody can hear me well, right? All right, excellent. So we'll get started. I think we have already exhausted a few minutes, so I think just before we start, just a couple of disclaimer, probably some things to get out of the way. Whatever we will be recommending or discussing is actually just a tech discussion, right? Do not take it or consider it as a financial advice or our bias towards it, because a lot of these things are still in a phase where we are just investigating or experimenting, right? So, as the topic suggests, I'm going to be talking about how you can utilize the Web3 ecosystem to build the next generation applications. And of course, there are certain use cases which has been built on top of Web3 technology. It's basically a two-part discussion. One is which I'll be taking, where I'll be just talking about the first principles, which is basically to set the levels, and then we'll have AB who will be taking us through some of the use cases, probably slightly deeper dive into those aspects. On the questioning part, just feel free to raise your hand if you have any questions during the session, or even after that. We'll be somewhere around here, so you can ask your questions as well. Okay. So starting with the decentralized applications, right? Because decentralized is the theme of everything, whatever we're going to be talking about. So decentralized application is a word which you will hear very often, especially within the developer community. The reason being so is the idea is that the applications will exist and run on peer-to-peer or basically a blockchain, right? Where it's not going to be hosted on a single system or a platform which governs it. So this decentralization of application actually, or at least perceived to bring a lot of value to the ecosystem purely from the perspective of security, and then even on the monetization point of view, right? Because the challenge with the traditional systems which has been in the past is that you will see that from consumer side there are a lot of users who are consuming it, but from the hosting side, from where the application is hosted, there is a centralized authority. It could be, if you're consuming Facebook, there is a Facebook there, right? If you're consuming, let's say, Twitter, there's a Twitter there. So there are challenges in terms of how, because end of the day, if you look at economics of network, we are the one, or when I say we, that means I'm talking about mass audience. We are the one who are contributing towards their economy. We upload the photos, we do the retweets, and they make the money. More often than not, they pay us nothing, right? So there have been a lot of discussion around how we can make it slightly level playing field, where we can also make some monetization or money out of it, and that is what the intentions behind this whole technology. Okay, on the agenda side, so I'll be talking on three basic things. One is, we'll be starting with the prehistory of the blockchain, which is how things were in the past, and then we'll touch base a little bit on the Web3 as a technology, which empowers this whole blockchain discussion, this decentralized applications discussion, and then I'll also take you through some of the use cases of the Web3, right, and how you can use that to build your blockchain application, or even if you're not into the blockchain, build your decentralized applications, right? Because just the way we have evolved in an application hosting side from monolithic to 3-tier to n-tier to microservices, this, you can consider this as an extension to that as well. Okay, coming to the historical part of it. So if you look at the history, how should we start with this, right? If we are talking about blockchain or a decentralization, that means there have been some problems in the past which we are trying to solve. One of the most important use case of the blockchain and Web3 technology is the cryptocurrency, right? And that doesn't mean that's the only use case. There are a lot of other use cases which has been built over a period of time, but currency is probably the most used use case, purely because Bitcoin was a solution that was built on top of it, right? So if you look at a traditional approach of a payment, how things was happening in the past. So let's say, and I'll take an example. So let's say there are two people, Alice and Bob, right? And they do exist in the physical world. So what Alice did, he decided that I'm going to pay Bob $100. So what he will do in a physical world, he'll walk up to the Bob, he will take his wallet out, remove $100 bills and pay it to the Bob. Now that's fine in the physical world. But when it comes to online payment system, that's where this model might not work. So what you need in that case, you probably need an intermediary, right? Which we these days call a bank. And the reason for that intermediary to exist is because you need somebody who can track the balance of Bob, the balance of Alice, and then the actual transaction which has happened in between on some ledger or somewhere. So this is what challenge which you have with the online. Of course, this is the way of doing online transaction, but the challenges in this aspect is, firstly, this intermediary, because he is managing huge amount of infrastructure just to track Alice and Bob's transaction, that means he needs to have some value out of it, right? It's not that he's doing some charity. More often than not, that value is in the form of some cut, some tax which he charges you back. If they are not charging you that back, that means they are taking your data and probably using it for, I don't know, maybe some targeted advertisement purposes, right? So then the security becomes a risk because you can't trust the kind of data which they are doing. And then of course, the time it takes and everything else in the process, that tax cut is actually a troublesome. And just think for a moment, why can't Alice and Bob do this transaction in an online world like they do in a physical world? The fundamental challenge, if we allow that, is what stops Alice to transfer Bob $100 and make a copy of it and send it to Carol, send it to, let's say, ABC, anybody, right? Just like emails. So we receive an email, we can send it to a number of people. So you do need some trusted party which can actually have a look at that whole transaction and verify and say that, okay, Alice, I'm reducing or debiting $100 from your account and then adding that to the Bob's account, and then put that transaction into a ledger. And while doing so, verify if transaction is legit, commit that, right? So that third party becomes very, very important. And there have been a lot of innovation, a lot of talks around how we bring this peer-to-peer communication into online payment world. Second problem this challenge had is some statistics, right? If you look at the whole of internet currently, probably 35% of the people are not into the banking domain, and I'm talking about across the world. Which means if you bring online payment through the internet and the banking system, you are excluding that portion. On the contrary, if you look at the people who have mobile devices, that data goes up to 90%. So 85 to 90% of the people actually uses mobile, and in most of the cases, smartphones, right? So if you can bring a peer-to-peer communication while doing these payments, it becomes a lot more easier. And that's the thought process with which it all started with. Of course, on the fly, on the way, you will see a lot of people who try to solve these problems. Unsuccessful, of course, right? So, one fine day, I think in somewhere in October 2008, during the financial crisis, there is a guy, or at least he presumes to be a guy, who actually wrote a white paper. His name is Satoshi Nakamoto. What he did, he wrote a white paper called Bitcoin Peer-to-Peer Electronic Cash System, right? He wrote it very eloquently, so it's a must-read document for everybody. It's a 6-pager where he talks about a lot of things, but most importantly, he talked about all these things using technologies which existed for decades. So he never invented anything new, he just used those existing things to build something which is unique. Now, there are a lot of things, as I said, which is there in that white paper. I'll leave it for you guys to kind of do that read. But there are two things which is very important from the discussion which we're going to have for the next 1 hour. One is he claimed that I have a solution for peer-to-peer cash transaction system, right? And second thing which he claimed, that I also have a solution for double spending, right? The problem which I was talking about that existed or that hindered the whole cryptographic invention for over a decade. Now, people said that it's huge because it actually was a huge thing, but they never believed him. They said that, it sounds to be good, but it's very, very difficult to be true, so show me. So by 2009, I think January, he released the first draft of the code of that, and then people started using it. And if you look at very simply what it did in a very nuanced terms, we all know internet, right? So what it did, he said that I'm going to release a distributed ledger, and I'm going to use some of these words which I'll define later, on top of internet. So you still use internet. He released or put a payment protocol, if you may call that, on top of the internet, and he called it as a distributed ledger. The idea is that now every peer, when I say peer, every node within the network will have a copy of this distributed ledger, and then there will be some sort of consensus mechanism through which every transaction will be verified, whether it's genuine or authentic or not. So that's what he did. And now once he successfully did that, there was big challenge in that aspect, like how you will make sure that, that because it depends on the network, the number of people who validates the authenticity. So there has to be a way for people to make money out of it, otherwise nobody will participate in that public network. And that's where he brought this whole concept of tokens with a small b, small caps b, right? Wherein anybody who's participating in that network, validating the transaction, at the end of it, there's a chance that he might receive a bit of Bitcoin, right? And the numbers varies, right? When it started in the beginning, I think one thing which is said that there'll be 21 million overall Bitcoins, and then every 10 minutes he will release the Bitcoins, and whoever is participating in the network, they'll earn that. So it started with 50 Bitcoins per 10 minutes, and I think currently it's somewhere around, I don't know, maybe 6 or 6.5, somewhere in between that, right? So that's the monetization part of it, where people who are involved into that whole public network to verify these transactions can earn money. And now that network is, yeah.
Some intermediary fees. So when you say in cryptocurrency, when individual person can participate and they can validate that transition, so can you elaborate a little bit on that particular part?
Yeah. So I'll come to that part in a bit. I will, right? As in how this whole process of validation works, right? And that's where I said that if especially in the context of Bitcoin, how it is happening is that there are number of people participating in the public network,
Okay.
and there is a, let's say, for time being, let's say that if 51% of the computes decide that this transaction is valid, then it's a valid one, right? So there is a consensus mechanism on top. Now, for anybody to be able to make or frost that or be that 51% of compute, as it stands today, you probably have to buy all the supercomputers and everything else as well, right? Now, every technology, whether we talk about Bitcoin or Ethereum and others, they have a different mechanism to validate that, right? Sometimes they do it on the basis of stake, sometimes they do it on the basis of proof of work and other things. I'll come to that piece later, but that's what they do. They work on a consensus to make sure or to validate that transaction.
And the validation happens just, the percentage is calculated based on the 50%, say for example, one transition is correct or, it is valid. So what is the percentage ratio, you guys consider for, right now you said, say for example, for a valid transition, it should be 50%. So most of the case, it is 50%, or sometimes it's maybe going to 90% or something, or there is any different mechanism or something?
Yeah, so as I said, there are other mechanisms. There are I think 3 to 4 mechanisms which exist currently.
Okay.
Bitcoin, when it started with the proof of work concept. So the proof of work concept allows them to use this mechanism where depending on the number of nodes who are part of that whole network at that moment, so let me give you a slightly different example, right? So there's a lot of focus about consensus here, right? Because there's a peer-to-peer, there's no third party which is validating everything.
Yeah.
Now, let's say, I'll take another example. Let's say a username. If you're managing a username, in a normal circumstance, you'll validate who owns that username. That's the validation, right? If @Utkarsh is owned by somebody, he's the user. In the context of this, it's not about who owns that. What this network accepts that who owns it, right? So let's say if this network or this public network says, or 51% of the people says that you own Utkarsh, then you own Utkarsh. Now the challenge is for second person to stand up and say, you know what, I'm also Utkarsh, is very difficult, because then he has to make sure, he has to manipulate entire system, right? Which is actually 51% or more than 50%. Now for him to do that, it requires huge amount of computing. That is where everybody says that, right? Mining process and other things are very huge in that nature.
Got it.
Yeah.
Got it. Thank you.
Yeah, we can discuss that later also. All right, coming back to the point which we were discussing, right? So, of course, when Bitcoin became used, there are a lot of other altcoins and Ethereums and other technologies which emerged. Now, the discussion which we're going to have is not about Bitcoin, right? So it kind of came in between, but the point of discussion today is going to be Web3, at least from my side. which means there is a number Web3 that idea is that there must be something Web1 or Web2. So probably, as I said, that's just to bring some first principles into the conversation. So Web1, in my opinion, this is 15-year cycle, right? So for 15 years, internet was working on the Web1, which was basically a read-only concept, wherein on internet, whatever existed, you just consume that, right? Amazon was one of the first adopter of that. So the first website which we had was just a catalog where you can go and see things, right? So it was basically a magazine. You have links, you can go and validate. So there's no way you are providing data back to the system. You're just a consumer of that, right? So that is why it's called read-only system. But then human tendencies are like that, we want something more. So we wanted to get a personalized feeling, and that is where you needed to have a two-way communication. That leads us to the Web 2.0, wherein a lot of these applications or apps which we are using on mobile or even on our systems, they are Web 2 based, in which on one hand, the applications or the server which is giving us the data, but then on the other hand, we are also providing some data back to the server. And as I was saying in the beginning, that the data which we are providing at times that is being misused for targeted advertisement purposes as well. So let's say, for that matter, let's say if you logged onto your Twitter profile and I log into mine, the chances or there is 100% chance that what you will see is totally different than what I'll see. How that is possible is because you are giving your data back to the system, which it is crunching, and all these technologies like ML and other things that is being used to provide you a very personalized view. Now, of course, what we did in this whole aspect to get access to these cool apps, we actually compromised a little bit on our security or giving access to the data which we actually share. And that challenge, or when this becomes used, especially I think a couple of years back when Facebook got into that situation where they released a lot of personal or PII data to an ad agency, this topic came into picture as in what next. And that's what Web3 tries to solve. So the first thing which I said, that decentralization of the applications that can run on the network in a peer-to-peer manner as compared to a server, is what Web3 is all about. So if you see, if Web1 was a read-only, Web2 was a read and write, here in Web3 you do read, write, and you actually own the data. So now the data which you put is not owned by, let's say in this case, Facebook, but it's owned by everybody who's part of that network, right? And of course it's immutable, so it's very difficult for somebody to go and change that data unless you actually manipulate the whole system which I was talking about. So Web3 is a technology, if you may call that, or let's say a principle on which a lot of these new innovations which took place. And that brings us to the technology which is built on top of the Web3 is blockchain. Now, we talk a little bit about this in the blockchain. If you look at the building blocks, and there could be a few more, I've just put 3 on the right hand side of mine. So you see the distributed ledger, right? That's the backbone of a blockchain technology. Now remember, whenever I say blockchain, I think from the perspective of all these nodes having, so if you all are nodes, so you have some distributed data which is with everybody and same data, right? And that is where this distributed ledger, the word which you see, becomes very important. So what is blockchain then? At a very ground level, blockchain is nothing but a ledger. Ledger is a bunch of credits and debits which gets recorded. That's what ledger is. Now, ledger is the blockchain? In a way, yes, but then the sheet of a ledger, if you consider like multiple credits and debits getting recorded into a sheet, that is qualified as a block. Then if you have a block, each block in that network needs to know the state of the previous block. That means some way it has to be connected, right? The chain of blocks has to be there so that you can trace back to the origin. All the blocks are connected in some way, right? So you have a chain of blocks, and each block is a sheet of ledger, and then actually the transaction which is recorded in that ledger, that's what you do, let's say, doing anything for that matter. And if you distribute that, that is what your blockchain is. So blockchain is a technology, just one thing just to make it very, very clear. Is there gonna be a blockchain? Answer is no, right? Is there gonna be the blockchain? Then again, answer is no. Anybody can create their own blockchain. Bitcoin started with its own blockchain. Ethereum has its own blockchain. Of course, the underlying technology or the mechanism which has been used to create that blockchain remains same. More often than not, it's a decentralized using the Web3 and these sort of technologies. But the principle is very simple, that anybody can create their own, and that is where the blockchain technology adopted by these use cases like Bitcoin or Ethereum or some others, they solve different problems. So underlying things remain same, but still you can have different use cases, right? So distributed ledger is what I said at the beginning, is what Bitcoin also did, that they brought it or put it in on top of the internet to solve that problem. Now the second most important thing is the consensus mechanism, right? Because I'll tell you another problem, and which I think somewhere in the 80s that or that paper was written. If you have heard about Byzantine generals problem. So what that problem was, that in the Byzantine Empire, there were a bunch of generals who invaded or tried to attack an enemy city, and they were camping along with their troops. Now the challenge was that these generals were using messenger. So they had to formulate or agree on to a strategy to attack. Again, the problem is there were few people in that network, you call them traitors, but they were trying to mislead the whole communication. Now the solution which they are looking for is, can there be a mechanism using which the loyal generals reach to a consensus for a pattern or an idea how they're going to be attacking it, right? Of course, there was never a solution to it, and that's the solution which Satoshi Nakamoto actually proposed, right? And how he proposed that is by using these consensus mechanism. Putting everything what we were discussing during that conversation as well is, there are multiple ways in which you can do that. At the moment when it started with proof of work concept, in which how you will create the consensus depend on the network itself, right? And he believed at the beginning that the network will become so huge that it will always be, and of course the data is immutable, so it's very difficult for anybody to forge that, right? So consensus becomes very important. Over a period of time, because there have been a lot of talk about the energy consumption and other things when you do the mining and participates in these public blockchain networks, there are other strategies, right? Like there is new, which I think now Ethereum is moving towards that, which is proof of stake, right? In which, let's say, if you can be, an individual can be given an authority to actually validate that this transaction is valid. But how he does that? He has to own X amount of Ethereum, right? It could be, that means you are participating in that with $1 million investment. So the chances are that you trying to forge something is very less, because there is a lot of stake, right, which you have, because you're part of that network, and there is a financial penalty if you forge something, like even the smaller of the transactions. So that's another thing which is happening in this context or concept of consensus, where a stake can be identified depending on the amount of investment which he has made, and he becomes the validator, or he becomes the deciding factor. Then on top of it, you have smart contracts. Now, smart contracts is just a piece of code which runs on the blockchain. So like, as I said, blockchain is a distributed ledger running on every node. Smart contract is actually a piece of code. You can think, if you're an AWS user, think of it like any Lambda or any function which can run on top of it. And then, there are certain functionalities which you can perform using that. So these are the few building blocks of blockchain. Now, because of course we are from AWS, so we have to talk about how AWS can help you in this whole journey of blockchain, or using Web3 to build your next decentralized application. I think one thing, again, I'm going to re-emphasize: do not consider that all these things, if you have to get into this technology, you have to somehow build the next cryptocurrency, right? There are different use cases which you can solve. It's very, very important for everybody to understand what portion of their application require that. So let's say if you are using any application today, not every portion or not every functionality of your application requires to be decentralized. Not every application requires to be centralized either, right? So identify what can be centralized, what can be decentralized. Of course, in Web3, you can use these technologies in a different way. Let's say if your requirement is that you want to have a cryptographically verifiable, immutable data, which I'm talking from the Bitcoin and other cryptos perspective, then you probably don't need decentralization. You can still use a centralized database, like in the context of AWS, maybe a QLDB, right? Quantum ledger database, that does all these same things, but in a centralized manner. You still have that third party through which you can verify that. So remember, identify the use cases, and then if it requires you to adopt towards this Web 3.0 technology, which allows you to do the decentralization, make a move towards it. Now, what we at AWS do, we do the heavy lifting on your behalf, right? Because we believe that creating let's say a private network of blockchain or participating in a public blockchain, so I'm getting into two different types of blockchains here, is not that easy. So we have these services which empowers you to adopt those technologies at a much faster pace, and we always gonna be a pioneer in that, right? And that's what I'm going to be discussing in the next few minutes. And this is what I was talking about, identification of the use case. So if you look at on the left-hand side currently, right, we are talking about a centralized, right? Now, this is QLDB, by the way, right? So if the idea is that you want to have let's say transactions getting stored in a way that they are tamper-proof, then you probably be looking at a ledger-based database which allows you to do that. But if in your application there is a requirement where a decision has to be made on the basis of consensus, and I'll go back to the same example which I said, that if at the rate Utkarsh has to be decided by the people participating in the network, then that's a use case for you to go towards the decentralized model, right? Now, when you do that, there is Amazon Managed Blockchain. What Amazon Managed Blockchain does, it's again set of tools or features that allows you to literally solve any of your workload problems, right? Whether you talk about centralized or using QLDB, or whether you talk about decentralized using managed blockchain. I'll come to managed blockchain in a bit. Okay. So this is a sample architecture. This could be any use case. You can think from this as an NFT being in the marketplace, or you're building something new. So what are the common components which you normally will see is something like this. And this is what you normally see when you talk about even the Web 2 or these sort of adoption as well. There are a few things, of course, which are moving. So you have user, you have personal wallet. Now, wallet is nothing, I mean, you can consider it like just like your wallet. The only difference in this wallet, and I'll not go very deep into it, is that this wallet is not actually keeping the currency. That's a myth, right, which we have, that, okay, the wallet is the one where my coins or my tokens resides. I normally consider this like a credit card, right, which has a reference, but it's not actually holding any value. If you just tone your credit card, it doesn't mean the data or the money which was there is gone, right? You can always go back and get a new one. So that's what this personal wallet does. That means you have a wallet where you're keeping some personal information or something which is secret. So on one hand, you have user interface, asset storage, API layer. Now, these three components or blocks actually represents what we normally have even currently, right? That means you have to have a way through which user start interacting. You have to have a data or a storage platform on which he can store the data, and then the API layer through which he can talk to downstream services or components, basically. If you map this with AWS services, so again, there can be multiple other services that you can adopt to. For the demonstration purpose, I have taken Amplify, for example. If you haven't heard about Amplify, it's a set of tools that allows especially front-end developers, whether mobile or web, to build their full stack application by just clicking here and there, right? So you don't actually have to put too much effort. You just use that, and if you're trying something new, this is probably the easiest way to do that. And then from asset storage perspective, the cheapest cloud storage platform, which is S3, the benefit which it has on top of it is that it's very durable, and in most of the cases, very difficult to get a situation where it's down, right? So it's durable plus available. So they talk about 11.9 of durability, which literally means that in our lifetime, we should not see a downtime. Of course, we saw that downtime, which effectively means in the next couple of life cycles or lifetimes, we should not be seeing it. But yeah, the crux of the matter is that from storage perspective, if you have a data which is very, very important for you, you can trust S3 with that. And then you have CloudFront, which is nothing but a content delivery network platform that allows you to cache or keep the content very close or in a close proximity to the end user, so you don't have to, you don't have to travel all the way back to the source to fetch the data. So it speed up the delivery process, right? So these three services maps to what we already know. On the API layer, that means how you communicate to the backend system. Of course, for any API, you need to have a mechanism or a functionality through which you can do sign up, sign in, or a user permission management. That representation is, that's what is being represented by Cognito here. So Cognito is basically let's say, authentication and authorization service in AWS. And then you have API gateway, another managed service in this whole stack that everything is managed actually, by the way, right? So under hood, AWS is doing the heavy lifting on your behalf. You're just interacting and consuming these services. So API gateway allows you to build, publish, secure, monitor, whatever terms you can use from auditability perspective, from security perspective. It allows you to do that just by making some selections there. Now comes the next piece, right? If you want to let's say, if you have a state or internal state during that whole blockchain or that Web3 applications where you will store it. And that is where there is the service called DynamoDB. Probably the, at least what I have seen, it's one of the better services or best services which we have, right? Purely from two perspectives. One is from, if you look at the performance, it gives you a single digit millisecond performance, right? Unguaranteed. And then it being a NoSQL database, it allows itself to automatically scale and other things that is very difficult for any relational or any traditional databases. So you can put your data onto DynamoDB, and then the remaining three services which you are seeing is basically about your analytics or a data lake if you want to build on top of it, right? So let's say if you want to have or a place where you can put all the data and then build a dashboarding capability, you will use services like Kinesis for streaming, and maybe a data lake, and then OpenSearch for full text search, right? So I'm just trying to kind of bring a synergy between how you, let's say if you're creating a workload or you're trying to create a workload, what are the components which you have to think at the beginning when you do so, right? Then the blockchain nodes, right? That's another interesting thing. I talked a little bit about it at the beginning, but what you can have, so on one hand you have Amazon EC2, which means that at AWS we have different types of instances. The one is specific type which is catered towards the blockchain needs, right? So that means there are different instance families and or type that you can use when you select EC2 as a platform. If you don't want to have that hassle, you can go ahead and use Amazon Managed Blockchain. Now, in Amazon Managed Blockchain, it's very simple. It's a managed service that allows you to build your platform irrespective of whether you are creating it for, you are creating a private network, right, a private blockchain network, or you are trying to participate in something which is public. So let's say public blockchain network is, let's say, in Ethereum, right, and you decided that I'm going to be participating in that whole network, then you can just go ahead and use a managed blockchain service. It supports two open source. One is Ethereum, so you can use that, and then it also support the fabric, right? So what it does, so if you are trying to build a, and that's some use cases which we have seen, especially in the enterprise domain, like, you know, if you look at the names like Sony or a BMW, what they do, they build their own private blockchain, wherein there is an inherent trust between the nodes or among the nodes who are participating in that communication. So the process of joining them is not straightforward, like in the context of public blockchain, anybody can go and just do that, right? Because it's a trustless kind of a system. When you go private, then there is a bit of trust which is inherent in the system, so you have to go through and follow the process, and then it depends on the person or the entity which is owning that private network, whether they allow you to get into that system or not, right? But if you're trying to build something like that for yourself or for your customers, that's also allowed using Hyperledger Fabric, right? So you can use that technology and do that. So both the open sources are supported when you go for managed blockchain. So if you're starting something fresh, the idea is that, you know, go ahead and use these managed services like managed blockchains, like these purpose-built databases, purpose-built compute services, or identity as a service, or maybe API as a service, and just get it done from at the beginning itself, right? The blockchain event synchronizer, that's a term which has been written here. So normally what happens, so when these nodes talk to the wallets and the contracts, right? So let's say the contracts which you write, it's not going to be instantaneous. You need to have a mechanism through which you are keep pooling polling here, and then the result has to be transferred back to the end user, right? So you need a system that can do that, and that is what you see a Fargate. So AWS Fargate is nothing but, it's a serverless container, right? So you can use any computing service there, but serverless container allows you to do it slightly faster. So it allows you to run a compute if you need a little bit duration for it to run, right? It's basically in the scenarios of pooling. And then you have DynamoDB, where you can keep this state and send it back to the user, verifying whether the transaction or whatever operation he was trying to perform is successful or not. And then, of course, the backend platform, whether you are using Ethereum or any wallet, or you have written any smart contracts. I think one inherent thing which I'll just talk about here, again, same representation of the same architecture, probably some different components. Here for the application development or website hosting, you can use S3, and then everything is bottom or top to bottom is same what we discussed earlier. But one inherent thing which is very important whenever you're building any blockchain based applications or anything which is on the Web3 is how you secure things, right? And I think there are a couple of services which I'm sure AB will talk at length about them, as in, in this whole discussion, the private key, because it's basically, a key-based system, right, where there is a public key, there is a private key. What we have known from decades is what involved there. And the security of your private key becomes very, very important. The moment, so network getting compromised, the chance of that is very, very rare, right? But your private key getting exposed is something where you have to have a little bit thought process behind it. And that is where, especially if you are into a use case of trading the coins, you have to be very careful about the kind of wallet which you choose, the kind of exchange which you select, because if they get tagged, all your data, all your private keys are exposed, right? So making sure that you have a system that is inherently supporting the security, and that is why I have not put security here. It will be from here to there, all across, right? And using services like a key vault or a KMS, proper encryption and other things is something that has to be thought through. Yeah? So I'll just leave it at that.